Hello and welcome to AI for Developers. I'm Chaitanya. Today's lesson is titled Generative Adversarial Networks. GANs. The Art of AI Deception and Creation. Imagine two artists competing, a forger and a detective. The forger tries to create fake masterpieces, while the detective tries to spot the fakes. This is the core of a GAN. Two neural networks, the forger and detective, battling each other to improve. In code, these are two separate models, constantly learning and adapting. The generator is a neural network that takes random noise as input and tries to transform it into something that resembles real data, e.g., an image, a song. Think of it as a function that takes garbage in and aims for art out. From a developer's perspective, it's a model with layers that process data, learning to generate more realistic outputs over time. The discriminator is another neural network that tries to distinguish between real data and the fakes created by the generator. It's like a sophisticated art appraiser. As a developer, you'd code this as a classifier, evaluating input data and giving a probability score, real or fake. The forger and detective play a game. The forger creates fakes. The detective tries to catch them. The detective's feedback helps the forger improve its forgery, creating even more realistic results. This iterative process, in code, involves training both networks using backpropagation, where errors are fed back to improve model parameters. Training a GAN requires lots of data and patience. The process can be unstable, sometimes the forger gets too good, and the detective can't tell the difference. Mode collapse, or vice versa. As a developer, you'll need to carefully tune parameters and monitor the training process. GANs are used for more than just creating art. They can generate realistic images, create new drug molecules, improve medical imaging, and even enhance video games. Developers are pushing the boundaries in many creative fields. We'll show a simplified example using a popular deep learning library, like TensorFlow or PyTorch, to give you a flavor of the underlying code. This will be a very basic example, highlighting core concepts. GANs are a rapidly evolving field. Research constantly pushes the boundaries, and new applications are being discovered all the time. We'll discuss some exciting future directions for this technology. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.